So today we're going to continue the Python lecture I had last time and go into the other important parts of the Python language. So this section we're going to talk about loop and conditional statements, and first kind of just go through code blocks again. So most code in Python are grouped in code blocks, and those are indicated by the colon and an indentation. So indented code has a meaning. So in this case here we have a loop, and this part here is the loop statement, and all statements that are kind of loop or define something have a colon at the end, and that marks the start of the code block. So in this case the print statement here is the code block that will be executed by the loop. And you can see also this part here is not part of the code block. So if I run this code here, the print statement will be executed multiple times for the loop, and the print statement is out of the loop. But if I just do like this, the print statement is inside the loop again. So indentation defines the code block that will be executed by the loop, or any other statement that for example, a function also defined using a colon. So there are multiple ways of looping in Python, or iterating. The most common one is using the range statement. And the range statement, simple form, you define a for statement, and then you have I, which is the loop variable, in, and then range here, which defines the range that you want to loop over. So in this case, the range statement defines that it starts from 0 and goes to, but not including 10, so less than 10. So the sequence will be 0 to 9, and you can see that when you run here as well. You can also do start, so there you can have multiple parameters to the range statement. Then you can have 5 to 11. This means that you start from the 5 and go up until, but not including 11. And then you can also have a step length, a step size here. So the third parameter is the step the loop variable takes. So it's often you are not required to, or it's very also not needed to use the range-based loop forms in Python, because you can iterate over anything without a range statement. So for example, if you have a list, I have a list here of values, I can loop over this list using a different form of for loop. So here you can do for value in values. And that means when you start this loop, it will start by going through the list, and the first iteration will take the first value and put that into the value variable here. It's like this. So if you're not interested in the actual position when you iterate, you can get a much shorter form by using the iterating directly on the list like this. But of course you can iterate over a list using a range-based loop as well. And then and the benefits of that is, for example, if you have multiple lists and you want to iterate over multiple lists, you can use the loop variable to access the lists directly inside the loop. So in this case I have two lists, and then I use I here to access the lists inside the loop. But to be able to loop over lists, you also need to know the length. So you need to specify the length of the iteration, and here you can use the length function again to query the length of the list. And because length will return the number of items in the list, it will fit nicely directly into the range statement, because it will loop from 0 to, but not including the total number of elements here. So that is one way of doing it. Then you can also be more sophisticated. So suppose you want to have the value and the loop variable. You can use the enumerate function in Python here to get both the value and the position. without actually accessing the index into the list. Like this. So you see you get the position and the value in the list as well. You can also just kind of see what the actual conceptual output of the enumerate is. You can convert it to a list here and see that it actually returns tuples with position and value. So when you're looping over, you kind of extract the tuple from each time you iterate, enumerate will return a pair with the index and the value, like this. If you just print enumerate A here, you will get something else here, which is not so interesting to look at, but you get an enumerate object. So if you to do efficient loops, Python never actually extracts all the pairs. It kind of talks to the return of this object here instead. So that's why I use the list here to show the kind of conceptual structure of the enumerate. But you can actually loop over multiple lists as well without using index or loop variable. And that is by using the zip function. And zip function kind of does the same thing as the enumerate, but it takes the list and extracts the first value from each list, combines that to a tuple, and returns that. So when you loop here, the first iteration will take 50 and 50 from each of the lists here and assign them to the variables x and y. And the next iteration will go 130, 70, like this. So using this, you can get both values without actually using a loop variable. And you can see here that it creates a similar structure to what enumerate does. So you get pairs of values in this case, looping over the list. You can also, so suppose you have a structure where you have lists in lists, and you want to iterate over multiple lists in a double loop, or you can do that as well. And here you can see you can nest loop. So I have an outer loop that would loop over the items in the points list here, and the items here are the internal lists here. So these values here, these lists inside the list. So P here will be, the first iteration will be this one here, and then you loop over P here in the next loop here, and then the cores will be the values inside the list in P here. So you can see here you go 50, 50, 130, 70, 220, and so on. So this is where you can nest loops. But you see here also the indentation important here. The outer loop, the code block for the outer loop is this part here. And then the inner loop, this is the code block for the inner loop of the chord loop here, or the loop over P. Then we have the data structure dictionaries, and you can loop over them as well. And one easy way of doing it is that you use the items method of the dictionary, and that will give you pairs of keys and values for the dictionary. So in this case, it will print Petra and the number here and so on, like this. And same thing here, if you print the dict items here, you can see here that it comes out like this, like tuples that you can loop over. So it's similar to what you do with enumerate and zip. You can also, if you're only interested in looping over the dictionary or the keys of the dictionary, you can use the keys method here. That will return a list of keys, and then you can just loop over those keys, and then use, for example, print key, and then I can access the dictionary with that key I get out. So then I don't get the value. You can extract the value yourself. And also, other way around, if you want to loop over the values in the dictionary, you can use the values method here. That will return you all the values in the dictionary. If you don't interested in actual the keys for each value. You can just loop over and get the list output of the values. There is another loop statement, and that is the while statement. So this is more of a, if you want to loop until a certain condition is fulfilled, you do while, and then you have your condition here. Same thing with the for loop, you have a colon, and then you have an indented code block. So here I do an iteration here for convergence, and then if I run this, I get the output here. So while is more, you do some kind of algorithm that should converge, you can use that one. Conditional statements, yeah, that's also an important thing in programming. Use the same concept. You have an if statement, colon, and then a code block that is executed if that condition is fulfilled. So in this case, if I equals 0, it prints out this statement here, and that belongs to that statement there. So it's only executed if this is true. Then you can have multiple, you can also have else statements. So you have if I equals 0, otherwise else, it prints this one. And then you see here that I have a code block for the true condition, and I have a code block for the else condition here. And then you can have multiple, you can nest if statements. So you can do if then else if, else if, else. So we can have multiple nested if statements here as well. And also, just to kind of see, you can have a, in the else, if you have to make sure that you have the right things in the right code block. So in this case, I have if I equals 0, it will execute this one. Else here has another else statement that is only executed, or if statement, if the first one here is false. So you see I have indented this, and that's belong to the else block here. You can also control iteration in Python. You have two statements that you can use, break and continue. So break exits the loop. So if you do break here, it will continue here after the code block. Continue will go to the next iteration of the loop. So it will go back here and do the next iteration. So in this case here, I have a range of 20, but I have a condition here, if I is 10, I should exit the loop, and then I do break. So this loop will only go to 10. You can see here that it counts up here, and then you see here, if I equals to 5, it prints go to the next iteration, and it kind of goes back here, never prints out I, it just continues here to the next iteration. And then you can see here, exits the loop, it uses a break here to go out of the loop, and you can see here, we end up here below. So 11 and so on is never executed.
Stupid question.
Yeah.
You have nested loops.
Yeah.
And so you have I in range 20, and then for j in range 4. And then in the inner loop you have a continue. Is it always the last loop, or do you go to the very first?
Only the last loop. So you continue to the iteration of the continue belongs to the kind of outer, the innermost.
Oh, the innermost.
Yeah.
Okay.
So you continue that one.
Okay.
Then you have to continue in the other one as well, if you or break. Yeah. So it's only the current execute.
That you can go 4 loops above, or?
I don't know. I have to check.
Might be.
I think it breaks the current loop.
Yeah. Okay.
Yeah. So then you have to have 2 breaks.
Okay.
Yeah. Let's see if we can see it. No help. Yeah, I need to check that, but I think it's the current loop only. Yeah. I think there are some tasks here you can do if you want to, but yeah, we can do this one first. I do it together here. So if we look at this one here, okay, skip that one. So let's see. We just take this code here and we paste it in here. Can you see some errors? I think my editor is too helpful here. You see some errors in this code. Sorry?
It's the colon for the
Yes. More?
it also makes the closing bracket.
Yes. But there is one more. If you look at the for statement
Colon
here.
after 20, range 20.
So this one here we found, and this one here.
The indentation.
Indentation.
Yes. Like this. So if I have run this code here, you can do that for illustration purposes. I think we'll fail on indentation first. So you can indentation error. So we fix that and run it again. And now you see expected colon that we found. And then it said never closed. So you get some hints here from Python as well. So, and now it works. Yeah.
So how is indentation interpreted by
You,
Python environment? Because the single space here,
Yeah.
there's one indentation, but it will collapse multiple, I guess.
the important thing is to be consistent. So if you, in this case here, you have an outer block here that is indented here, and this, if you do like this, it's Python will kind of figure this does not. It's inconsistent with other indentation.
But in this particular setup you have now,
Yeah.
the for statement that you're at and the print statement following are the same code block, right?
Yeah.
Despite having different indentations.
But you can see here, if you don't have a colon here, Python doesn't expect an indentation here. So then you can it says, okay, this doesn't fit with a outer level indentation. You can actually choose to have two spaces. If you consistently do that, it works. But it will check that it doesn't. It's consistent.
Okay.
And I usually set my editor for 4 spaces and consistently use that. There are some tools also which are all very useful, that can automatically fix the indentation before you save. Then you also get if have the wrong thing, your code doesn't work either. So you have to fix it very clear where you have problems. But it's something that you have to get used to if you come from other languages. I code a lot of C++, and there you decide yourself where the indentation should be. But in Python, you need to be consistent.
Should I?
Yeah.
What does that last print command without anything in the parentheses actually do? Because I just tested to comment that out, and that changes how the print actually comes out in the end. What does it do?
So an empty print statement will just do a return, print out the return character.
Oh, okay.
So it will go to the next line, and that's why also here there is an option in the print statement to have a different. If you don't want it to return after a print statement, you can add this end option, and then it will put out another character instead. So when I print here, it will print out on a single line here until the last, and then the print statement here will go to the next line.
Oh, that's interesting.
Yeah. You can have anything here. So yeah.
Thank you very much.
Yeah. You do this on your own. I will remove those because that shouldn't be there. So function and subroutines. So just like the for loops, functions are also defined by using the colon and a code block. So you define a function by using the def keyword, followed by the name of the function here, in this case print doc. You always have to have a parenthesis. Even if you don't have a parameters to the function, you need a parenthesis to define a function. And then you have a colon. And then the code for that function will be defined in the code block following the colon. So this will be a print statement here. And you can see if I execute this, nothing happens. It only defines that function in Python. And then I can call the function just by giving it the name and a parenthesis afterwards. So this is the simplest form of function you can define. No parameters, no return values. You can have parameters to your function. Then you just give a parameter list for the function here in the parentheses. and then you can use that variable inside a function. And here you can see I can have a variable here, print, and give it to the function. And of course, you don't have to have the same name for the variable that you call the function with. So in this case, I have a b, and then it prints out 42. Then I have a what happens if you change a variable in the function. So suppose you have the function here, print value, then I do a equals to 84. What will this print here? So I have a print b here afterwards.
42.
42. Any more guesses? Yes. So a variable coming into function is a reference to the variable coming in. So it's a pointer to that memory location. And what you do here, a equals 84, is actually reassigning the local reference. The variable inside the function is only local to that function. If you do a equals 84, it just creates a new memory location, and a inside the function points to that instead. It doesn't affect the outside variable. And that is mostly true in Python. Everything you pass to the function is kind of, you can't change it in the function, except if it's a list. For list, you can change the context of list coming into a function, but you can't change the variable to it. A function can also return a value. So in Python, you can see there is no distinction between a subroutine that doesn't return anything or a function.
Sorry, could you just?
Yeah.
I think that was
too quick.
So here we would say, if I now would do that one and call the variable a,
yeah,
42, and then print value a. So that's again 2 times 42.
Yeah.
Even a was redefined.
So a here is a reference to 42, the memory location 42
yeah.
in memory.
Yeah. But if a is now an array.
Yes, if it's
a list.
A list. If you modify the values in the list, it will be also modify outside.
Ooh.
Yes, that is something you have to think about in Python. I mean, if you pass only scalar values to a function, that's no problem.
Mm-hmm.
But if you pass lists, it's also a feature. I mean, you can change lists inside a function. So if you pass, we can do it. We can see here. We can do a code section here. So a equals to 1, 2, 3. Mm-hmm. Then I need to define a function here as well. Then I do a0 equals to 42 like this. Mm-hmm. And then I call the function here, modify list a print. Then, what do you think? It will work? Yeah. Mm-hmm. So, the thing you are doing here is that a here actually creates a new reference to a new memory location. So it kind of discards the current reference mm-hmm. it's already pointing to. And that reference is only available inside a function. You can't use it outside anymore.
So the point is the list is a global variable?
No, the list is, you post the list, but the list contains references to values in memory.
Yeah.
And you can't change the items in the list inside the function. And so in this case here, a here points to it's a local variable pointing to the list that you passed over. The list is in memory of the computer, so they both point to the same list.
Okay. So the difference is that here I have not created a new list.
No.
But if I would in that list write a equals something.
If you do like this, a equals to 1, 2, 3 inside here.
Yeah, and then do that. Then you get again 1, 2, 3.
Yes.
Oh.
Because you repoint it.
Yeah. So you create something new, and the local variable reference is changed. So you can use an input variable as a variable in the function, and you can reassign it there as well. But the outside function can never get those things except for it when it's a list, because then you modify that. I keep it there, just an example. But I will remove this one here. Yeah, just put it like this.
Okay.
So
Yeah.
there's something you have to be aware of, that that is what happens in Python. You could have passed a tuple. Then if you want a list not to be able to be modified in a function, you can pass it a tuple. And if the function tries to modify that, you will get an error. So a tuple is kind of a list that is read-only. And that is enforced. So if you pass and actually you can pass a tuple to a function taking a list, and if the function doesn't modify the list, it say okay, or the tuple. But if it tries to modify the tuple, it will fail, because you can access a tuple just like a list. The only difference, if you try to assign something to a tuple, you will fail. Yeah. Yes.
Is that the proper way of passing arguments that don't want to have modified, or are there other protect keys?
I think there is no protected keys in Python, so you can pass anything, but with tuples you can enforce that the intention that you don't want it to be modified.
Like I have a print function for a convoluted object, right?
Yeah.
I don't want to modify the object; I just want to print out the information about it.
Yeah.
So to enforce modification, I should close it tuple environment, or
that's
the proper way of doing those things.
That's why also you return values by a tuple. That is also read-only. So default is that you return value, and it adds a tuple around them when you return them out. There are some other things, I don't go into that in this course, but in the newer version of Python you can also enforce types. So you can actually say that the input variable should be a float. And then actually when you run it, it will actually enforce that as well. So you can't call it with different things. But by default, you can call a function with anything. Yeah.
But is it still stored in the memory then as this generic Python object? So even if you force it float, you will not save any memory, is it right?
No. It's just a coding that forces coding safety.
Coding safety.
Yeah. So if you want to kind of make sure that I have a function here, it is intended to only be operated with lists, for example. I can say this function will only take a list. And if you call it with a tuple, it will fail. The same thing, if you expect it to be integers in a function, you can add type attributes to the function. And then it will enforce that at the call. But by default, Python has never had, this is something that they added very late now. So the default is that you can take anything. And that can also be a feature. But there are ways now to enforce that. So another way you can, if you want to get something out of a function, you can of course send a list and modify that. That's one way of getting things out of a function. But the common way of getting things out is using a return value. And a return value, you use the return statement to return something out. And then you can also return multiple values here. So that is also supported, and you can actually have as many as you like. The only thing that you actually have to catch them. So if you have a function that returns multiple values, you need to have a variable for each of them. And you can't have just take one. You need to take both. So let's run this here. You can see here that I have a function here, normal, and that returns the sinus value of x. But I also can have a function that returns two values. But if I skip that one here, okay, then you got a tuple out, so you actually get what you wanted here. So in this case, it actually prints it out a tuple. So apparently, yes, I was wrong there. You can do that. But usually the rule is that you need to kind of have the number, especially if you want to expect a single value and you try to use a tuple, you get a problem with that. So if you have two values returning out, you should have two variables assigned to them as well.
So I can never be sure of what I get back unless I actually check.
Yes. Yeah, I mean, it's Python. So.
It accepts everything.
But it's consistent.
Yeah.
Yeah. So that's also, if you have multiple values, it returns a tuple. So 3 values is contained in a tuple. So x here, in this case here, is a list of values. So if I run this again here, you can see here that this is a list of values. So both variables, the function return 2 values, and they are caught in a tuple. But I don't think it likes if you do like this. It also works. Interesting. Yeah, that's because x, y already assigned up there. That's why I reassigned them here. So you can actually skip catching the return values as well, but that's perhaps not so interesting. Now I have the exact example I had before with a list. So in this case here, the same thing. I have a list here. I modify a value inside here, and you can see that it actually modifies the list. So let's do a short task here. Let's see here. I should have emptied this out here. Okay, then I can do it. So if you want to define a function like this, you do def f of x colon, and then you do 2 times a return. Okay, the AI already added to me. It's okay. No, but you could actually also do change it here to 2 times x 2 like this if you want. Also, so you can use the raise by operator here in Python.
And that works as normal, right? With parentheses assigned priority.
Yeah. That's one thing. Python doesn't change from other languages in this case. Yeah. Then, so now we have all the building blocks. So now we want to organize ourselves in yeah. Sorry.
Can I have a short question?
Yeah.
Before we continue?
Yeah.
When I do that in practice and read other people's code,
Yeah.
I get always totally confused because there are so many methods and types of variables and things and functions which are almost doing the same, but differ very little. They do almost the same, but differ very little in detail.
Yeah.
They may be good for a numerical thing, and they make the code shorter, I fully understand. But how does one do that in practice to read such a code? Because I always encounter methods I've never seen, or I have totally forgotten. If there's a fortune code, well, there's a certain number of things which you know, and you hardly encounter anything else.
But yeah.
So there you know these 30 buzzwords, and then you're done.
Yep.
Here you get something new every time you show something. I have now the append method for the list and the remove method for the list, and I do not know the del method for this.
That's the thing is that Python actually has built-in help functions. So if you have a function, anything here, so if you go to the sinus function here, for example, there is help built in. But you have Python has a really large runtime library of functions compared to Fortran, which has a limited number of.
Yeah, Fortran, you know them by heart after a few days or months.
Yes, but I have.
You will never do.
Then also Fortran lacks rich data types.
Huh?
Fortran lacks a lot of rich data types. So that's why most of the things I've shown here is built into the language. The dictionaries, the lists, the tuples are kind of native data types.
Yeah.
But they are objects with methods. And then you have to go to the Python runtime, the documentation, and look at what the methods actually are.
Yeah.
But there are not so many. I mean, append is one.
Yeah.
You have what I showed you yesterday here, the len function.
Yeah.
And there are certain kind of that are generic for everything. So you don't have to know too many of them to kind of do most of the things you want to do. And also the dictionaries and lists are very similar in how you access the brackets. So that I think the data types are kind of familiar. If you know one, you know the next one. So But I agree, there's a lot of things that is more because you have so many more data types. You have more things to write complicated expressions with.
Yeah.
But math expression in Python is not that different.
No, math is not the problem.
Yeah.
But the problem is all this list handling and,
Yep.
or for example, that you have range, arrange, and linspace, and they all do more or less the same thing, but they differ a little bit.
Yes, but that, now you're into Numpy, which is
No, but
yeah.
okay, but
Yeah.
that's
So-
but this is what is always confusing because you always forget which was which.
Yes. Then you have to kind of learn some of them
Yeah.
and consistently use them. That's what I try to do. I mean,
Okay.
Numpy hasn't changed that much either for those basic things.
Yeah.
But I agree, the Numpy is also you can do. Compared to Fortran, you have. I agree. Fortran is simple and elegant in some sense because you have an array, but the array itself is not an object. It's kind of just a memory location and a way of accessing the elements. But if you have a NumPy array, it actually has it knows how to do certain things, and you can. It's built in, and then you can also do operations with multiple arrays and do expressions with them. So they are more. They have more rich. Metadata, so to speak.
No, I see the point. But how do you do that in practice when you have that memory in your own that you do not remember that there is the append and there is the del and there is this method?
I think the only thing is to use it. So try to write code using it, so you get it into your kind of spine. That those methods are there.
Yeah.
And it takes some time, but then after a certain while you kind of get into the mechanics of it. And I don't have any more better recommendation than that. And hopefully I can kind of give you some hints about how to think about it. I mean, I show the most important things. There is much more. Yeah.
I know when I read code from other people, it's obvious.
I guess it's sort of important to see that richness as a feature here. I mean, you document your code properly, write out this is what I want this piece of code to do, and you think about, okay, what should this piece of code do, and there's probably a function or a method for it, rather than in many other sort of simpler or elegant, more elegant languages. You have to think, okay, I want to do this to the list. I need to write a little piece of code that does this. You might then get it for free, but you don't have to write that little code. So if you're just clear on, I want to manipulate exactly this data this precise way, find the correct function for that through documentation and use it.
I would also recommend one more thing. It's actually having an editor with code completion. Because if you have an array, you press a dot, you get a list of all available functions or methods of that object, and that helps a lot with your memory recollection. So I think that helps a lot, because if you're using an editor with no intelligence, you need to use your own memory recollection functions to get that. And if you want to code today, there's a lot. Most of these are object oriented, have perhaps 10, 20 methods that you can use, and then you see, that was that one I wanted, and I just press enter and continue. So that is also helpful.
Well, nowadays you really just ask OpenAI, right? I want to do this.
Yeah, or
some code, and you check that it actually does what.
Yeah, or use something like GitHub Copilot, which will kind of, if you do dot, it kind of suggests how you want to code as well. So you have a lot of help today to get all those things sorted. But I still think that Python is a really easy language to learn, and you don't have to learn anything. Certain functions you need to learn, like len, like range and a-range and linspace. Those are important, and you have to learn them. That's the only thing. But there are not so much many more that you need. But all the other ones, more specialized things, you can find in documentation. And with IntelliSense dot.
I mean,
and that works in Spider.
Sorry?
That works in Spider, for example.
Spider works, and also Visual Studio Code has that as well.
Yeah.
And there are, I can suspect much more editors that do that as well. So now we are into organizing ourselves. So regarding organization in Python, that is actually quite elegant in that way. So you already use, to be able to get functionality into Python, you use modules. And for example, if you want to do math functions, you can use the math module, import math. And those modules can be both extension modules compiled. So most of the modules in Python are compiled in C. So the math modules is C code. But you can, and if you want to use a module, you just do import and then a module that you want to use. If you do, yeah, sorry.
No, I can complete that.
Yeah. So if you want to use a module, you import it, and then you get the module available in your code space or your namespace where you're coding. And then you use the function in the module by prefixing it with a module name and the function name. That's one way of doing it. There's also one other one that you can use, that is the from import. That will import all the functions or specific functions of a module. And then you don't have to use the prefix math anymore. That can have a problem where there is a lot of modules that actually define the same function. For example, Numpy defines sine as well as math, which can be problematic if you first import Numpy and then math. Math overrides all the sinus functions again. So from is a bit complicated. But you can also do just import the functions you need from a module using from import and then the name of the functions you want to use. I will get back more when I go to Numpy. You can also actually import and give it a different name. Yeah.
This were a few questions, but just the few times I looked into Python, people talk about Python libraries, and now you say modules. Well, these the same thing or different things? Or modules,
they're the same thing.
Or, okay,
in Python, a module is a library.
Okay.
Yeah.
Okay, preferred import stuff then, because the sort of one of the detriment of Python code is, of course, you import the entire world to get the sinus function.
Yeah. And
does it really matter nowadays, or should
it doesn't.
I just import this big library and then use the little things?
It could be when you're getting my code is really slow at startup.
As Python.
Yeah, but
can be.
Actually, if you look at what happens in the beginning of a Python, if you do Python and then your code, it spends a lot of time in the import statement, especially if you have star import.
Right.
Then it will kind of parse everything and it takes some time. So, but no, you can do star import if you want to. But it's not, the encouraged way of importing thing is not using star and also not using the from. So you should use an import statement like this one here.
And what are the differences? Because to me, those two sort of do the same thing.
Yeah, but with
helping
from
me later on to write it simpler.
With from, you take every function, import them in your world. So the functions will be directly accessible. But the problem is that you can have modules with the same name of the function when you do import, and then they will the last one takes over.
Okay.
So with import, you will import the namespace of the module into your module. So you will make sure that you don't have any clashes with namespace. So in this case, math here, you will need to prefix with math to get the functions. You can do also what I show with, for example, if you use Numpy, the preferred using Numpy is import Numpy as MP. And then you can do import math as M here as well. Then you can prefix with just M. That is the preferred way that they recommend in Python world to do it. But sometimes if you want to have simple expressions without the prefixes, you can do the from. So it's but the recommended is using with the prefix.
But the first and second blocks I can see here, they sort of do the same thing.
Do the same exact, yeah.
It's just that it helps accessibility in the code.
And it also reduces the pollution of your own namespace. So so if you have all functions will be available directly in that namespace. You had a question as well?
What would be the difference between using a mathematical function that is in math and Numpy?
If you have scalar values, none. So the problem is if you import the math functions and you try to use them on arrays, they will crash. So for example, if you start by importing Numpy and then you start importing math. Math will overwrite all the NumPy functions, and then you can't use arrays. So if you want to have, if you're working with arrays or matrices, import NumPy and use that. Because NumPy, the default functions in NumPy also can handle scalar values or scalar variables. So they are kind of the same, but they can also handle arrays.
And I guess if you have speed critical code, implementation is different, right?
Yep.
So maybe you want a quicker, better written
Yeah.
sort of code.
But is there any advantage to use math rather than NumPy?
If you don't use arrays, or you want your code to be able to, you can't rely on NumPy. You can use math. But,
Yes,
but math can't do anything more sophisticated than normal.
but NumPy can do everything which math can do.
Yes.
But maybe not exactly the same way.
Huh?
No.
Maybe not exactly in the same way, right?
Yeah.
So if implementation matters.
Yeah. But math is part of the standard Python runtime
Okay.
library. NumPy is not. NumPy is an extension module that is provided by another project. So this is the standard Python way of doing math.
Okay.
But NumPy is kind of optimized for working with large arrays.
Yeah.
And the functions are also parallelized. So you can use, when you do sinus on an array, it will compute the sinus on all values in the array and return that. So that you can't do with the Python functions built in.
And that would be way quicker than doing a loop.
Yes. So that is also a thing, I will come to that later.
Yeah.
You need to avoid loops in Python if you want to do computational code. And then we have to go into the array libraries.
But in practice, when you have imported NumPy, you don't use math anymore.
I haven't done that, yes. No, I haven't done that yet. I usually just only use NumPy.
Yeah, okay.
Yeah.
Just as a practical.
Yeah. Because you get in trouble when you're trying to mix and match.
Yeah.
Okay, so yeah, I have come to that. So you can also, the nice thing with Python is also, you can define your own modules. And modules in Python are defined just like a source code in Python is a module itself. So if you have a source code file, for example, I have here a file here that contains this code here. It only contains a function and the required imports. If you save that to as a source code file, you can use that as a module in your own code. So you can create your own module libraries by collecting the code in source code files. So I just need to, because I'm in a notebook, I just downloaded this here, and so I put this part here in a file called prime.py. And then if I import it here, okay, didn't. So now I imported my own source code file in my own execution environment, and now I can call my function here, prime.isPrime here. So to doing your own modules is just put your functions in a Python source code file, and in your other code you just import that source code file, and then you can use it. But you import it by specifying the name of the file without the extension. So Python will look for your modules with .py extension and import those. And then we have also, there is a difference in Python. There is no main file. So if you execute a Python source code file, it will execute directly. So there's no need for a main file. But sometimes you want to distinguish if you, in your own code, want to know if it's imported or executed as a main function. Because of you can import anything, the import actually executes the code as well. So sometimes if you have a main Python script, you don't want it to be imported. You want to kind of know, is it executed as a script or imported? Because that is two different things. Import is done when the Python interpreter is already running, and then you call import. When you run it as a script, you do Python and then the Python source code file. So in this case here, I have the same thing again. I have my prime I modified here. I added this one here, print name. There is a special identifier in Python called name, and that is gives you the current module. So if I let's see here, run this one here, you can see it printed out prime extra. So I this one I call prime extra, and I added this print statement. So that gives you the name. So if you import that name will be set to the name of the module if we do a normal import. But if I do Python and that source code file and run that, you can see here that the name changes to main. So if you execute a file, source code file with a Python interpreter, it will set the name to main. And that is a way of checking, okay, the user has executed this as a main script. And then you can do certain things in your code to handle that. So one thing to do is, in your main program, if you want this to be a script that is called and executed on a command line like command, you can put if name equals to main here, and then you can execute, okay, then I start my computation here, because now it started as a script. So this here will run this. But if I import prime main, the same function here as an import statement, nothing will happen. So if I would have removed this one here, it will actually execute that when you do the import as well. So this is so if you see this in code, this is the reason is that you executed a script or not a script. So there is a distinction. You want to kind of be able to, in your code, determine if this module is imported or executed. Yeah.
Clear case where I want the module to be handling both situations.
If you write test files, tests for you, you can, for example, have a module if you want to have, so you can just run the module and have the tests in the main section. Yeah. Or you want to kind of prevent people from running it as a script, so the code doesn't execute if it's imported, for example. Yeah. Okay, I think we'll take a 10 minutes break here. So another thing that is important when you do scientific code is able to actually format your output, because just printing out arrays or printing out things can look kind of awful. And Python has a lot of functions for formatting your output. And I will start kind of first showing a bit more complicated ways of doing it, and then finish off with a really easy way that they have added to the later versions of Python, which makes it much more easy to format. But the basic way of doing it using object-oriented is use the .format method. So a string has a .format method which you can pass variables to, and that will put those variables into your string. So for example, here I have a string here with a format statement, and I have 4 variables going in. And then I can use placeholders, and those are curly brackets in your string. Those will be replaced by the variables. So A will go into the first curly bracket, B, C, and D. So this is kind of a not so useful example. You just put everything in a string. It looks something like this. So we can notice here that the comma and spaces here will be put between here. So it's kind of a template of how you want your string to look like. But there is no kind of formatting regarding floating point or anything else now in this. It's just kind of taking the values, putting them in the string in a certain way. You can also, the ordering can be changed. So if you want to order them in a different way, you can actually specify a number in the curly brackets. Then A will go last, B will go here, and so on. So it can reorder also directly in the format string. But the interesting thing is that you can also affect how it will output the things going into the string. So for example, here I have a formatting string here. I want to put Python 3 in a string, and I want to have a certain character width of my string. And then you can see here, I can do :15. And 15 means that it's 15 characters wide. And then I just put this here to kind of so that you can see where actual spaces go, because it's otherwise kind of hard. So you can see here on a print, I have my Python 3, and it adds spaces here so that the output is almost 15 characters wide. Of course, perhaps you want the Python to be on the right side. Then you can use a larger than operator here. You can look at this as an arrow. You push it to the right. So in this case, the Python will go on the right side here. You can also center. So then you have the circumflex operator here, and then it will center the text in the string like this. So you can see here that you can use this to kind of tabulate data. Yeah?
But you can just write it in the argument. You don't write from string. You could just write it the right-hand side to the argument of print.
Yes, of course. You don't have to have a string. You can do it, exactly. You can have it directly in the print statement. Yeah. Okay. It's 2 steps, but you can use it in a single step.
Okay.
Yeah.
All right. So, of the simpler example that you scrolled past now, obviously, if I have strings containing curly brackets, to escape these, if I want to format the string but still retain, for example, 2 empty curly brackets somewhere, because that's...
Then you have to do something like this, and then have another curly bracket like this.
So that would escape the first one.
Yeah.
Okay, good. And since you used in that example with the Python 3 here, the next one, you have 2 functions of these angles, right? If you go 1 block below. There, right?
Yeah.
So inside the curly bracket, it has a specific function. Next block, the one that's at 60. Yeah. So there you have sort of characters, and in the middle, it has a function.
So this here is a code form, type codes.
Right.
So you have a certain syntax of that to control the output. So colon here, you can do. There are some other things you can put to the left of the colon. I come to that. Yeah. And right here is the field width and the kind of alignment.
So within curly brackets that are not escaped when I format strings, I need to be very careful about how I do this, right?
Yes.
Great.
Centering, and then you can also change the placeholder, what kind of field character you should use. So before of course, it's very nice when you use it correctly. So then you have underscores here instead. So strings are kind of one special case here, but the only thing you want to do is handling of integers, floating points, and so on. And so if you want to kind of formatting integers, you can put a D, and then you can set, same thing here, you can have the number of field widths here. So 10 here is the width of the field that you want to put here. So usually you use this in the combination with, if you want to do a table. If you want the tables to have the same column width all the time, you can use the formatting 10 and for each column. And then you get a nicely formatted table. And also you can control where the number is going to be placed. So integers is kind of the same as strings. Then you have floating points, and here you have more things to control. So you have fixed point, floating point using the F character. So this is similar to what you do in C. So here you have the field width comes first, and then the number of decimals with dot, and then the number of decimals. So 10.2 is 2 decimal points, 4 decimal points, and 6 decimal values. So let's see what it looks like this. So default, it's right side aligned. You can also use the alignment here if you want. And you can see here I have 2, 4, and 6 here.
And then obviously, how does this formatting handle overflows?
I think it just puts square brackets or something. So So it overflows to something so it doesn't display anything.
So I want this to be 10, right? But I put in a string that's 12.
Yeah, then I think for strings it will just truncate, but for floating points, I think it just puts square brackets there that it can't format.
Does it truncate or round?
Yeah.
I need to look documentation here. Yeah, I don't want to answer that.
you have the answer there, at least in the 64 number.
Yeah, it rounds.
That one rounds, but that's
And then you also have the E code, which is for scientific notation. So if you do E here instead of F, you will get this one here. And I think you also have a G code, if I'm not wrong. Or is that Fortran? Now you have G code as well. G is kind of chooses the best one depending on the output. So F is for fixed, never changes. E will only give scientific notation, and G will kind of select the one that fits best. Now we get into more nice, interesting things. So you can also have named placeholders. So if you have variables going in here in your format statement, you can name them in your placeholders. And then you can use, for example, a dictionary here with values. And then you can use the dictionary as input here. So value 1, 2, 3. And then you give it a certain really strange parameter here to pass the dictionary into the format statement. So you needed 2 stars in front of it for this to work. So this is a nice thing to kind of get, have a nice template of which you actually can read as well. And the interesting thing is that everything in Python when you code is stored in the dictionary. So your functions, your variables are all stored in dictionaries in Python. And there is a special function called globals in Python that gives you all your variables and all your things. So for example, if I do print globals here, you can see here I have a lot of stuff here. Basically, all the code I have defined and all the variables are available here in my globals as a dictionary. And what I can do with that is actually, I don't want to have to specify anything. I can just have my values defined in my code here. I pass the star globals into the formatting statement. And the values here are actually picked from the values I have defined here. But you don't have to use this. You can use the next form, which is the F strings. And F strings are kind of the method I showed you here, but in a syntax variant. So in this case here, I have value 1, 2, 3 here, and I put a prefix on the string called F. And that tells Python this string will have formatting values inside it, and you interpret that automatically for you. So if I have 3 values here, I can just print them out by putting curly brackets here and kind of automatically get them into my printing statement here with formatting. So, but the interesting thing is you can put value and then you can specify your how you want it to be outputted here. So you don't have to do you can specify directly here. You don't have the dot format at the end, and you can reference the variables directly here. So you can see here that I formatted a string here with widths as well. So F strings are really nice. You can use all the syntax of the placeholders as I showed you, but just reference the variables directly and print them out. I think this, I'm sure it's one of the later versions of Python that this was released, and it's extremely powerful. Yes. Next thing we also need to cover here, reading and writing to files. And that is something you will do, and you will either read input from a file or write output results and so on. And in Python, you do that using file objects, and you create a file object using the open statement. Very similar to other languages here. So you use open, and then specify the file you want to open, and then the second parameter is if you want to write to that file, if you want to read is R. So W is write, R is read. There's also an A, which is append. So if you have an existing file, you can append to that file. That returns you a text file object. So you can see here we have objects again. And with the text file object, you can actually write data to the file. So it's not if you have in C, you get a file pointer, then you have to pass the file pointer to a function. The text file object has methods for writing. So in this case here, I use textfile.write. So you have to open that like this. And then I write here. And write is not as flexible as the print statement. So write will kind of just continuously write to the file. Each statement will kind of continue after the next. So if you want multiple rows, you have to specify control characters here for new line. So in this case, this will be written and then the next statement will be written just after that. So let's run that. And then when you're done with your file writing, you need to close the file. Tell the operating system, I'm done. Because many operating systems, they optimize file writing. So they don't write to disk immediately. They write to a cache somewhere. And if you want to really to kind of make sure that, okay, now it's okay for you to write it down to disk, you tell the operating system to close it, and that is done with the close method of the text file object. And then now I have a file here which I can just display here. And you can see here that this part here was written, then next write continue to write on the same line until the new line character. So it's really simple to create files. Same thing, reading back, you have to specify R here instead. You open it the same way. And now, of course, Python is Python, so you have multiple ways of reading again. So one thing you can do, if you have the memory in your computer, if you have a large file, you can just do content equals to text file read. That will read the entire file, put it in a string, and you can use that. Of course, you have to be prepared that the string could be gigabytes if you have a gigabyte file. So it's not useful in every case. But if you have small things, it's very quickly to do that. There is also a method called read. Read line that will read a single line from the file. So read until the character return and then return that. So in this case here, this line here will read a single line. And if it's at the end of the file, the string will be empty. So you can use a while loop here to loop until the line is empty. And then you just continue reading line after line like this. Here you can see here that it actually reads also the character return. So if I print them out, print will actually add a character. So that's why we have two spaces here between, because you read the character return and then also you add a character return. What you can do then, if you are not interested in it, you can use the rstrip method to remove trailing characters, and a \n is a trailing character. So running this again here, you will get a single line per row here. But of course you can do more. You can also actually, just like you have a list, you can actually iterate over a file. So you can do 4 lines in a text file, and then it will read a single line every 4 loop iteration. I think this is a really elegant way of doing it. And then if you want to process a text file, you want every line to be accessed by an index, you can use the read lines method. That will give you a list of where the list contains every line in the file is an item in the list. So that sometimes when you do processing of input files, it can be nice to have a random access to that file. And you can see here that you have first line here, second line, next item in the list like this. And finally, I will go through the with statement here. And one thing you notice that I told you it's important to close the file. And to make sure that this happens automatically, even if something crashes, you can use the with statement. So instead of opening and getting a variable, assigning a variable, you can actually use the with statement. So with open as text file, : So now we have a code block. And then you can do read lines here. And that guarantees you that the text file will be closed. So even if it crashes, it will close the file. And I think it's a good idea when you do files, always use with statements with file when you open files, but then you guarantee it will also call the close method of the file and tell the operating system that the file has been closed. I will don't go too. So just briefly on error handling. So of course you should program in a way that you kind of make sure that if you want to read a file that it exists before you actually read it. So one way of doing that is using the runtime library OSPath exists, and then you with open file open. Otherwise you print out some error here. So now instead of, if I didn't do that, you will get an exception and the program crashes. So handle errors gracefully. I mean, if you want the users to kind of feel good with your code, you shouldn't just present them with raw Python exceptions. You should kind of handling the errors. But what you can also do is you can do handle the exceptions in a way as well. So for what you can do, for example, you can use a try. So try colon, that is a code block. Everything in that code block, if there is an exception in that, it will go to the exception section here and print out something went wrong. The problem with this try statement, as I said here, it catches everything. You actually don't know what the actual error will be. It could be that there is something else that catches the exceptions. And so you shouldn't, this is kind of just an example here. It will catch every error there is in Python and just print the file couldn't open. But there is actually an exception for not finding a file. And then you can have, if there is a file not found exception, then you handle that one. And then if there's something else going wrong, you get that exception separately, or the program crashes for some reason. So this is the recommended way to actually handle the exceptions that occur in a nice way. So running this here will go here. Then there is also, you can have multiple other errors as well. So file not found is one. You can have permission, you're not allowed to open the file. Then you have permission error. There could be a value error, for example, if you want to translate values from string to floating point to string, something goes wrong, you get a value error. Those are documents. So one thing you can do is if you run your code and you get an exception, there is a name there, and you can actually extract that name and catch that. So then you can see with exceptions you want to handle. Yeah, you can also, an exception is also an object. So you can have except file not found as E, and then you can actually query more details of your exception. So e.filename will actually give you the file name of the file that was caused the exception. So you can also get the string of the error here using the str error method or attribute of that object. Okay, I will skip this here, and I need to continue to the Numpy part, so you have some part of Numpy as well. So I go over here. So as we already discussed this a bit. If you are working with arrays or larger data sets, or you work with vectors and matrices and multiply them in a different way, you should definitely not use lists or any data structure based on lists or dictionaries, because they are really slow for computational code. They are very flexible if you want to handle multiple data in different ways that are and use the dictionary as a dictionary, then they are fast. But if you want to multiply arrays with each other, you shouldn't store them in lists or multidimensional lists. And one way of handling is using the extension library called Numpy, which is an extension library that implements all the matrix operation, also the handling of arrays in C. So this is I'll try to kind of show you the basic data types here, and it's a bit different from the normal Python way of thinking. So I will go through those. So Numpy, the convention to import a Numpy is to use this statement here: import Numpy as MP. And then that is also so instead of prefixing all your function with numpy, you just put np dot. So it clearly indicates in your code that you're using a numpy function. The basic object in Python, or the most important object, is the array object, and that kind of handles a continuous memory block of a certain type in memory. So you don't handle individual items in it. You allocate the complete block of memory for the array, and then you work on that. So how do you create an array object? Yeah, really simple. You use the array object. So here in this case, I do a equals to mp.array, and you pass it a list of values, and you specify data type. It's not required to have the data type, because you can also, Python will figure out what comes into the list and use the data type in the list to determine what array to create. In this case, I create a floating point array, and you can see that when you print it, that it has a dot after each number in it, and then it's floating point. If you don't do that and you don't specify the data type, it will create an integer array. So arrays can have different data types. They can and you have to specify data type. That doesn't change during the lifetime of an array. So that's also important to know. In MATLAB, you only have one data type in an array, and it can be integer and floating point, vice versa. In here, you have to specify, or Python will figure out for you. And also, if you give it a floating point list, it will be a floating point array. But if you want to make sure that you want to have a specific array, you give it a data type. Yes?
If there's one value in it which is floating point, it converts the entire array into a floating point value.
Yes, so we can try that here.
Why does it float always dominate the integer values?
Sorry, what?
Floating point values always dominate the integers value, although you don't specify it to be a floating point value.
I don't know.
She said the floating value dominating all the type in this array. Although you didn't specify 2 and 3 as floating.
No, so it will look at if there is a single floating point value in the list. It will convert that, yes. But also, I didn't read it, so.
You will just redefine that array with all the integers, and then the last array value will be 2.0.
Yeah.
And then it prints out the array to be entirely floating point.
Yeah.
Why does this happen?
It's a convention that they have set in NumPy.
Well, it's a really great convention because working on arrays, you need one data type in order to optimize. And if you were to drop the float, you risk losing position on stuff. But converting integers to floats will not lose position. So you don't want to drop floats, because then you might have weird effects.
But if you really want to make sure that you have a certain data type, add a second argument. So say that, okay, I want a floating point. Then you can actually give the input as integers. So like this one here, this is an integer list, and I put floating point here, and it will create a floating point array. Yeah.
And if I now not put the float there, and now redefine a of 2 to be pi, what would happen?
I haven't tried it, but we can try that. Do you mean if we do this one here?
The integer list. Yes.
So if I do.
And now I redefine a of 5 to be, or a of 1 to be pi.
Hopefully that's an error.
And pi. And then I print a after.
Yes, I have to print as well.
Yeah, but it didn't. It's just going to round it. Uh-oh.
Oh.
Oh.
So we need to be aware of those things, right?
Yep.
Yeah, okay, good.
Python doesn't do things.
NumPy just do things.
Okay, NumPy.
Yeah. So
This
don't
happened
blame
in
Python. Yeah.
Well,
So if that would be a list, it would not be a problem.
No. Because the list will reassign a floating point to that position because
Yeah,
it can have
precisely.
multiple
Yeah,
data
yeah,
types.
okay.
But an array can only have a single data type.
And that is not changeable after you create it.
No. Then you have to recreate it.
So if you just happen that it is complex at later stage, then you're in trouble.
Yes.
So if you do
Yeah, trouble. It's very easy to, of course. Yeah, but it's still. If you notice that you also have a problem that a copy of a large array is a significant operation,
Yeah.
and you don't want to do that. So you want to be right directly, somehow.
Yeah.
You don't want to do that conversions without wanting it to happen.
Yeah.
Yeah.
That means you specify everything as complex at the very beginning.
Yeah, if you expect that, yes, yeah, but that could also be inefficient. So,
No.
yeah,
Okay, yeah, I get the point.
yeah,
If you define A as all floating numbers, and then like just give A, the first element in A to pi, and then it should be it will print the array again.
yeah. So if you use the, let's see here, this one here, and do A0 equals to mp.pi, print A.
Okay.
Yeah.
This means it's better we always define the numbers in floating type, because if we're gonna update later on,
Yeah.
that can be very
Can be expensive, yeah. But creating arrays like this is a special case because it's larger arrays you can't create like this because it's really inefficient having to specify a list in brackets. I will get, and then you always have to specify the data type. Or yeah.
If you don't expect floating points, I guess you shouldn't use float arrays because then you won't get the optimization for integers.
yes. If you are sure it's always integer, then that's fine.
So integer arrays are, I mean, if they are smaller, you can store. I mean, that's so. If you only use integer arrays, you should definitely use just integers. Okay, we have to continue here. It's really nice that we have a discussion here. So you can have multi-dimensional arrays, and you can have many array dimensions in arrays in Numpy as well. It's not like they are defined as matrices or vectors. You decide. So in this case, you specify a multiple array. You can have a multiple nested list here, and you can have same things as before. And you can see also if you print arrays, they know how to print themselves. So they will print themselves like in the right shapes. It's like MATLAB in that sense. Also, you have when you think about arrays, sometimes you think about two-dimensional data structure, three-dimensional data structure. And that they're stored like that in memory, but that's not the case. So if you create an array, it's actually just a linear block of memory in your computer. It's just that you interpret it as a two-dimensional array. And Numpy stores arrays, and there are two conventions of doing that. You have the C way and the Fortran way. So you can see there's a heritage here from Fortran as well. But in C, you store in memory row-wise, and in Fortran you store them column-wise. And you just have to know that, because if you communicate with Fortran code, you need to create your arrays with Fortran column-wise. Otherwise, Fortran will get something else and it will interpret it completely differently. So in here you can see that we have an array that is 6 by 5. It will store them like this. So you go from in memory, they will go like this from row by row. And this is how it looks in memory, actually. Just like a bunch of numbers, one-dimensional array.
So row-wise is the
C-way.
first index.
Yes. So you go from 0 here, you go in memory, and then you go to the next row like
So
this.
changing the second index is close.
Yeah. And then in Fortran, this is completely different. You go this way. And actually, Numpy can actually create Fortran-based arrays. So there is a special attribute when you create an array, order equals to string f. And then we'll create array. And that's really important when we come later into mixed programming, where you need to create arrays that you can pass over to Fortran. So it will automatically handle that. Then also you can actually get, as I said before, an array is a more complicated object than Fortran array. And not really. The data is the same, but there is metadata here. And you can query the data of an array using the shape attribute. So if you have a one-dimensional array, you will get the shape is 4, comma. Then you have two-dimensional, you can have 2 by 2, and then you get 2 by 2 by 4. So shape will give you the shape of the array. You can, of course, you use it like this. If you want the rows and columns of an array, you can do r, c equals to b shape, because these are tuples. So you can assign them just like a function here. You can also query the number of dimensions on an array using the .nd property. So b is a two-dimensional array. And then there are some other attributes as well. So you have the shape, which you covered, the endim. D-type, you can query the actual data type of the array using the D-type attribute. You can also query the number of total number of elements in the array using b.size. And you can query the actual number of bytes for each element in the array. So item size will give you the number of bytes it's stored with. So in this case, you have a integer 64, that is an 8-bit byte integer. And then you can see here, item size is 8. And total size is 4. You can change the shape of an array. And now I will define some functions here that you don't have, ignore this thing here. Just say this is memory of A that will return you the memory address of the array. And one thing here that Numpy goes to really great lengths to avoid reallocating anything. So it will try to make sure that arrays are not, you don't copy and you don't reuse the existing memory. So here we have an array. We print the memory of it, and then we do a flat equals to mp reshape a 4 by 1. So we have here a 2 by 2 that is 4 elements, and then we reshape it to a 4 by 1 array. And then we do the same thing, we print the memory of that. So you can see here that I have a 2 by 2, and you can see that the memory here, location in memory, is actually the same as the A flat. So here you also have to be really careful when you do operations with arrays. It will avoid copying. That means also that A flat, if you write to that, will also write to A. So let's see here, we do that here. I wrote 42 to 00 of A, and you can see here that A flat also is 42. And that is to make it efficient. So you don't want to have, otherwise it has to do copying. And that is really efficient, especially if we have large arrays. We start copying, it's not good. But if you want to do that, you can also use the same as we did before. You can see here that you have some operations and methods that are common in Python. So copy is something we use for lists. You can do the same thing here. C equals to a copy. And now you can see here that C has 84 and A is not changed. And you can also see that the memory locations are different.
But if I don't copy an array, right, I can assume that it's probably the same.
Yep. Yeah.
In most cases.
In most cases, unless it has to do some, but I think it will warn. I think it can't do reshape if the dimension doesn't. The number don't change the total number of elements. It has to be the same number of elements for this to work.
But generally, no copy. I will retain the same.
Yes. Some more examples here. You can do reshape here to get it to a one-dimensional array using 8 comma. That is important. If you put comma 1, it is actually a two-dimensional array with 1 row. So comma will give you a single dimensional array. 4 by 2 And you can see here that memory doesn't change. Also, this reshaping here from 2x4 to 4x2 is not the same as the transpose. The transpose is a mathematical operation. It's not the same as you're doing a reshape, because that will kind of just put the items in the order where they came in. So be careful of that.
So transpose is also not allocating a new variable.
No.
That means when I did the transpose, also my original variable changes.
Yes.
So A dot transpose, assigning it to B, will still have A and B point towards the same there.
So if you now would print B afterwards, what would you get?
I haven't changed. I assigned B trans is the transpose of B.
Yes.
So B will still be the same. I haven't changed anything of that. It's still this original array here.
But it's the same data structure.
Same data structure.
Or same data.
Yeah.
In memory, they're the same, but they're two different things.
Yeah.
But if I then change B, I also change B trans.
Yeah, we can see here if a B 0, 0 equals to 84, print B.
And B trans.
B trans.
Yeah, sorry.
It should have an 84.
Hopefully.
But
Yes. So just keep in mind that Numpy avoids copying at all costs, and that sometimes it's a good thing, but it can also lead to some really interesting errors. But
if I do B trans would be 2 times B instead, then you would not have the problem.
Then we'll create a new.
Then you create a new one.
Yes.
Instead of transpose.
So if you do B times B.
Well, yeah,
C.
if B is here.
If you do like this here, B will be overwritten. It will create a new array and assign that to B. But we can this will be a new array. Because you do an operation and create a new array. We can try that as well. Do print memory of C. Yes, it's a new array.
But how can I see if it creates a new ticket or not?
You have
because
to
if I would have NP squared of B, it would be probably also a new one, I think.
If you do like any array expressions, you will probably most likely create a new array in that operation. But if you are using reshape, you will not. It's only when you kind of do operations it will create new values and it will create a new array because there are new values in it. But
I guess we should think about changing the data structure or changing the data.
Yeah.
Like those are two very different things. Reorganizing is just sort of the overhead of how do I look and access my stuff.
Yeah.
But as long as we're not changing the
but
stuff
transposing is for me an operation like square root.
Yeah, but you don't change the data in the array. You change how it is presented to you. This is how Numpy does.
Okay, good. I understand it, but it's very difficult because when do you need to be careful?
Yep. When you change the actual.
when you gain using indexing, so you gain to modify values in an array, you need to be careful. But if you do the normal operations with the functions operating on the array, I don't think you have to be too careful about that.
So the point is, transpose is not considered a function, but a reordering.
Yes, it could also be. Let's see if we do. We can do another example here. See what it does. So if we do c equals to np dot square root, you say, of b. See what it does. It must. Yeah, we will see. It creates a new one here as well. So transpose is actually kind of the same thing as reshape, but because it interprets the array in a different way. But square root is an operation; it creates a new array. So C here is actually different. So that's why I created this memory of function, and that is I thought it was built in that you could see, but you needed to do this really strange thing here to get access to the actual array that is allocated in memory. So that's why I defined this one here. So you can use that as well to actually check that if it's.
ID didn't work any longer.
Sorry?
ID doesn't work for arrays.
Yeah, I think so, but I'm not sure what it returns. Because Numpy, so ID is the ID of the Python object, not the array. So Numpy manages a C allocated array. So if you want to know if the C, so if you do ID, you will get ID of the Python object, not the array. So you can have multiple objects managing the same array. So Numpy can share arrays between variables in Python. That's why I need this memory of, to kind of really check what is the array and where is it allocated.
But B and B transpose are managing the same memory.
Yeah. So it's.
But it looks different if you print it out.
Yeah. Because those change the kind of attributes of the array object, not the actual data. So when you do reshape, it actually changes the attribute, not the data itself. Only how it's interpreted. I can keep that as a good code example. Then you can change the size of the array. So reshape doesn't change the size. If you want to resize an array, you can use the resize operation. And that will actually reallocate and create a new array. And it will actually use the data from the existing array to fill out the new array. So in this case, I have a 2x2, and it just kind of, I resize it 9x9, it just kind of fills it out with values. And now I have 12 o'clock, so I'm a bit late here now. So resize is one thing, but when you get kind of to work with real arrays, you need to create them somehow. I want an array by 10,000 by 10,000. I need a way of creating those as well. So there are some functions here that we can use to create arrays, and you can see there is very much familiarity with MATLAB, if you have used MATLAB. If you want to create an array 4x4, you can use zeros. That will create an array with zeros in it. And here, by default, it will create a floating point. So the default here, if we don't specify data type, it will create floating points. So you can see here, MP zeros is a floating point array. So it's only when you have the list here, the list interpretation, that you will get, by default, integers. But here you can specify, if you want the integer, you have to specify int here. Then it will be an integer array. Then you also have ones. Same thing as MATLAB. You give it the dimensions, and you get an array of ones. And here you can also use. I will get into this. I will continue next lecture here. But you can, if you multiply an array with a scalar value, it will be multiply all values in the array will be multiplied with that scalar value. So in this case, I can do ones and then multiply by 42, and then I have a quick way of assigning it a value all over the place, for all elements. Is it clear if I go a couple of minutes more? You can also create ranges. You were talking about that, a range, for example. That this is the same function as in normal Python, but it will create an array range instead. So it has the same kind of limitations and parameters. So 10 will give you an integer array from 0 to 9. You can also do, of course, you can have steps and stuff like that in that as well. You can combine a range with reshape to quickly create arrays filled with values from 0 to 100, for example. So I have reshape MP a range 100, 10 by 10. Then I get a 10 by 10 array like this. You can also give it parameters going from -10 to 10, and then you can specify floating point here as well to get the floating point. You can have a step here as well, just like in the normal Python function. Yeah. You can also create identity arrays by using the identity function. Then you get identity 1 here in the diagonal. But there is a function here. You wanted to know the difference between linspace and a range. And a range is when it works just like the normal Python thing. But if you want, for example, to plot things, you want to guarantee that you have both the starting point and end point part of the array, you should use linspace instead. Because then you can put the starting point and an end point, and those values are always guaranteed to be inside the array you create. And then you say that I want 10 values of that, and then it will do an interpolation between those. Same thing here, I have 20 here, then I get an interpolation from 0 to 1. And you're guaranteed to have the 0 is here, and you have 1 at the end here as well. Same thing with this one and that one. So a range is just a kind of stepping, but this one will guarantee to interpolate. So kind of two different things. Yes, and that's just quickly here. Array expressions. I have an array here of 5 by 5. If you add something to it, it will add that value to all elements in the array. Multiplication operator is not matrix multiplication, it's actually element-wise multiplication. Same thing, if you use mp.sin, it will apply the sinus function on all elements in the array. Negate will negate the values. If you add them together, it's element addition. And you don't have the sizes can be different here as well, so it will add anything together. Let's see here. Yeah, that's on matrix. If you want to use matrix multiplication as well, then you can use the at operator, or you can use the dot method here to actually do the matrix multiplication, because arrays in itself is not that it hasn't operations for creating matrix expressions. So you can use at here instead. There is also a special class called matrix class, but I don't go too deep in because it's going to be deprecated at some point. So they want you to go from using matrices to using arrays and then using the at operator here instead. That is what they want to do in the future. Indexing.
Isn't there matmul?
What?
Isn't there matmul?
No.
That was Fortran.
So Fortran has matmul.
Yeah, okay, sorry.
So at is matmul here. Yeah. Or a.a is also matmul. Indexing, it's similar to what you do with lists. You have brackets to access different elements. It's zero-based, so first row is 0, first column is 0. You can use both, have multiple brackets. You can also use this here. It's the same thing. Assigning values is just specifying an index and then assigning a value. Works just like it's expected to do. Then you can also do the indexing we used with the list as before, but you can do values like this. And then also, same thing here. When you do slicing and index access, it's actually doesn't reallocate anything. It will give you a slice of the array in the same memory location. So it's the same rules here. It doesn't reallocate if it can avoid it to do it. So here you can see that I have memory here. They are different, but they actually belong to the same memory block in memory. So it's just different views here when they do the slicing. I will try to do this in the later here, but you can read on here. I don't want to keep you here anymore, but there is more here. You can continue in the notebook if you want, and then I will try to do a short finishing that in the next lecture. Okay, thank you.
Thank you.